All right, so continuing on from the prior video, we're back up at the top, and now we're trying to figure out if a function is linear, quadratic, or exponential just by simply looking at the equation. So when you look at equation A, f of x equals 3x plus 2, based on what we saw below, does this look like linear, quadratic, or exponential? Yep, that is definitely an example of a linear function. On B, y equals 5 to the x. Does that look like linear, quadratic, or exponential to you? This looks like an example of exponential. Because my variable is in the exponent position. That says VAR for variable is in the exponent position. Can you look and pick out the one that is a quadratic? We haven't done quadratic yet. Do you think that that is C, D, E, or F? Go ahead. That is true. F is the quadratic function because I have an exponent of 2. One moment. Now we're going to move back on, and we are going to see if we can figure out, just by looking at a graph, if it is exponential, linear, quadratic, or neither. So when you look at A, so I see kind of this curve happening. What is this kind of a curve? Jayon? Exponential is the correct one. Pick out a linear function for me. Which one of these graphs would be linear? Cliff? B. B, we have a straight line. This would be an example of a linear. Now look and pick out the quadratic. Where do you find the quadratic? AJ? One more time.
Like which one?
Yes. C, D, E, F, G, or H? E. E down here, so he sees a U, he sees a parabola, therefore that is the example of a quadratic. One of them is neither. Do you see an example of neither? Sade? G. So we have this curvy line up and down. This is neither or none of the above. Those of you that are moving on to pre-cal, you're going to see these waves, and it's either sine or cosine, I forget. All right, so we're going to move on to the next part, and we're going to learn how to identify a function from a table. So on this print-off, there were lots of typos that ended up happening. This first one, linear was supposed to be at the top, so let's put that there. And in the middle one, we have quadratic. And this last one here is exponential. So we have to figure out, just by looking at the values and how they're going up, if they are linear, quadratic, or exponential. So it says up here, with a linear function, they have the constant, same, first difference, blah, blah, blah. You are adding the same number over and over again. That is the key piece right there. And we are generally just talking about the y's. The x's, they usually go up by 1, or in this case, they're each going up by 3. It is the y's in all of these that we care about. We don't so much care about what the x's are doing. So when we go from 4 to 3, how do we get there? We subtracted 1. How do you get from 3 to 2? Subtract 1. And how do you get from 2 to 1? You subtract 1. So I could tell that this is a linear function because when I look at each of these y's, we are subtracting 1 each time. It won't always be subtract. Sometimes it will be addition. So if you are going to add or subtract a number over and over again, that is going to be an example of a linear function. Quadratics are a little bit weird. I'm going to skip that one, and I'm going to jump over to exponentials for a moment. So up here at the top, it says, exponential have a constant ratio. You are multiplying by the same number over and over again. And once again, we are only focusing and talking about the y values. So when I look at this exponential function, I'm like, okay, so how do I get from 6 to 18? You could either add 12 or you could multiply by 3. But you have to be doing the same thing in every single part. So you're like, okay, how do you get from 18 to 54? Well, if I add 12, that wouldn't be enough, so maybe it's the times 3. And either in my head or my calculator, I went 18 times 3, yep, 54. 54 times 3 is 162. And so I can tell that this is an exponential function because I am multiplying to get to the next y value. The quadratic, I do a couple different ways. One moment. All right, we're back again. Okay, so on the quadratic, what I tend to look for is symmetry. So I see that on my y's, I have a 3 here and a 3 here, and so this is probably quadratic. The other thing that I look for on my quadratics is the pattern on the y's is just kind of weird and hard to tell. All right, let's go down here and look at A. So I'm going from 7 to 4. How can I get from 7 to 4? You could subtract 3. Good. When I go from 4 to 1, I also subtract 3 to get there. That's also subtract 3. And then that's also subtract 3. And so this is an example of a linear function because I have to subtract the same number to get to the next y value. That's how I can tell that I have a linear function happening. Let's look at B. Sometimes, maybe the ones at the beginning, sometimes they seem a little odd. And if it's hard, then start in the middle or start at the end and then go back to it. How can I get from 3 to 6 and 6 to 12? What could, yep.
Multiply by 2.
Okay, so if you go times 2 to get there and times 2 to get there. And then sometimes I just back it up and fact check myself. If I take 1.5 times 2, do I get 3? I do. So sometimes I do go out of order. All right, so for my y's, I'm multiplying to get to the next term. What is that an example of? Linear, quadratic, exponential. This is an example of an exponential. I can tell this is an exponential function because I multiply by the same number over and over again. That. We're going to jump down and we're going to look at E. That's what we're going to do next. No, we're not. We're going to start with D. I lied. All right, so on D, take a moment to look at your patterns on the Y's. What are you noticing? How do you get from one to the next? Do you see any kind of a pattern happening? So first you might say, okay, so to get from 6 to 3, I went minus 3. But 3 to 2 is a minus 1. Now I go plus 1 again and plus 3. So that, and so I'm adding and subtracting to get to the next one. So it's not linear. But what I do notice, I have a 3 here and a 3 here. I have symmetry. On your Y's, I have a 6 here, I have a 6 here, I have symmetry. So when I have symmetry on your Y's, this is when I know that it's a quadratic. Let's do E next. I'm going to go from 16 down to 8, 8 down to 4, and 4 down to 2. What operation could I perform consistently that gets me from one number to the next? Go ahead. Divide by 2. So when I divide by 2, that leads me to a point. Up at the top, it said that you had to add the same number over and over or multiply the same number over and over. So division technically isn't allowed, and we're going to see that when we try to write an equation. M-U-L-T-I-P-L. So instead of saying divide by 2, that's the same as multiplying by 1/2. That's right. So anytime you see division, that's the same thing as multiplying by its reciprocal. So we're multiplying by 1/2 to get to the next value. When I multiply to get to the next value, what is that an example of? Exponential. I'm going to pause and you guys do C and F. Feel free to come back and check the notes. So the next thing we're going to do is learn how to write equations from a graph or a table. So we just did this the other day. If you have a linear equation, we're going to start it off in the form y equals mx plus b, where the m is going to be the slope of your line, and the b is the y-intercept. So on a table, I'll show you what to do. On a graph, you might have to do rise over run. For the y-intercept, it says it's the y value when x equals 0. So on a table, if you see 0 comma some number, that number right there is always your y-intercept. So this is what I'm going to look for on a table. Back in chapter 2, we did quadratics, and this top one here, this is called vertex form. We're going to deal with this more than intercept form, which is what we have going on here. So this says that your H and K is the vertex. So we're going to figure out the vertex, and then we're going to substitute it into that. And then the general form of the exponential is a times b to the x. A is your y-intercept, and it says b is your constant ratio. That is the number that you multiply to get to the next one. So when we were just doing the chart, when you went through and it was like times 3 times 3 times 3 all the way down, that's going to be our b value that we do. All right, so on this first one here, type. So you should be able to visually look at it and tell me, what is that? Is this a linear function, quadratic, or exponential? It is definitely a linear. So if I have a linear function and I'm trying to write its equation, the first thing I'm going to do is start off in the form y equals mx plus b. So m is the slope of your line. Do you remember how to calculate slope by looking at a graph? Yep. We are going to do rise over run. So the other day when we had something like this, so we were looking for where does the line cross two grids in the background. So I see those 2 points. If you count up 3 over 1, that means that I have a slope of 3. Because I had to go up 3, right 1. Your b is your y-intercept. Do you see where the graph crosses the y-axis? No, where's it crossing the y? So the y is the up and down one. Where does the line cross the y? Right here at -5. That is your b, which is your y-intercept. So when I substitute the m and the b into my equation right here, you should get y equals 3x minus 5. On b, let's at least do the type. So when you look at this graph, what do you see? Linear, exponential, quadratic. I see exponential. On the exponentials, I have a very hard time trying to figure out how to write the equation from a graph. I actually make a small table of values, and I think that is much easier. So I'm going to do just a little side-to-side table here. What are the coordinates of this point right here at the bottom?
0, 2.
Okay. What are the coordinates of this next point?
1, 6.
Okay. And then the coordinates of this one? 218. Why do I keep writing 3? It is definitely 218. Okay. So when you have an exponential, we expect that you should have to multiply by the same number to get from one y to the next. What number do you multiply to get from 2 to 6 and then 6 to 18?
3.
You multiply by 3. So to get from here to here, you go times 3. To get from here to here, you go times 3. If you look back up here at the notes, it says that b is the constant ratio, or the number that you are multiplying by. So based on that explanation up there, b equals 3. Now I have to figure out what a is. So when I look back up here at the notes, it says that a is the y-intercept. Where does this graph cross the y-axis? At the 2. In exponential, its general form is y equals a times, not on screen, okay, there we go. Y equals a times b to the x. So once you find your multiplier and your y-intercept, Now you're in a position to just substitute those two numbers in. So I have y equals 2 times 3 to the x power. Hey, do not turn that into y equals 6 to the x. That would be super, super bad. That's not an okay idea. You are totally violating PEMDAS in your order of operations if you tell me that that's the same thing as y equals 6 to the x. Because order of operations says you got to do exponents first and then you multiply. Well, I can't finish out that exponent until I know what in the world the exponent is, and I don't know. It's just a variable. So we're going to leave it alone, and that is perfect form, right like it is. And let's go down and do C next. Well, I guess we're going to do all of them. Okay, so now we're doing like we did before. All of your y's are going up by 1, so I don't care about you. I mean, your x's are. I care about the y's. Do you see either a pattern or is it going up by adding some number or multiplying some number? What do you think you have here? They're thinking, I'm going to tell them because I'm making a video. I go from an 8 to an 8, and I see a 5 to a 5 there, and a 0 to a 0 there. So I see a pattern. When I see this pattern, do you know what I have going on here? I have a quadratic. So I have to figure out how to write an equation. So I have y equals a times x minus h squared plus k. That's my general form that I'm going to use in a minute from up top. It said that you should find the vertex. After you match and you see the symmetry, do you know where the vertex is now? Good. So the vertex is right here in the middle of all of that symmetry, located at 0, 9. And once again, if you looked up at the top, the x is what we would call the h, and the y value of the vertex is the k. In earlier chapters, a used to change. So you would have like this normal parent, and sometimes if we made a like 2, 3, 4, 5, 6, it would get like taller and skinnier. And sometimes if we made it a fraction, it would get wider and open up. But we're in just general algebra 2, and so a is going to be 1. So we aren't going to have a number there. So I'm just going to substitute and be done. Y equals x minus 0 squared plus 9. So this is how I would start it, and then I would go, oh, it's kind of weird to add or subtract 0 to anything. And then I would just clean it up a little bit and rewrite that as x squared plus 9. All right, one more and we're going to finish out this video. On D, you're going to look at the y's and figure out what does it take to get from one value to the next. Are you adding, subtracting, or multiplying to get to the next number?
You're adding 3.
Okay, you go plus 3 to get there, plus 3, plus 3, plus 3, plus 3. As it turns out, these numbers that you are adding, that tells you the slope. So I can tell you that the slope is 3. Oh yeah, hey, so if you're adding 3, what type is this? Linear, quadratic, exponential. Linear, I have definitely a line here. Okay, so in general, in slope-intercept form, I'm going to use y equals mx plus b. So I know what my m is. So I have y equals 3x, and then I need my b, my y-intercept. It's up there within the table. Do you see the y-intercept? Where is it at? Here it is. Absolutely. Good job. It is right there. That is the y-intercept at 0, -7. And so I'm going to finish that out at y equals 3x minus 7. Good job. We'll do the rest tomorrow.